Everybody, welcome back to AtCoder. Today we have another AtCoder Beginner Contest. And it's sponsored by Caddy, I believe. Caddy. I'm not sure what is this company all about, but supposedly they're cool guys if they sponsor contests. I mean, they value clearly competitive programming, so they should be cool. That's all I can say for the introduction to this video. I noticed that the setters are almost the same as the last time, which I kind of like. Let's see, but let's wait and see how it goes, because you never can be 100% sure. But hopefully everything will be smooth today. Submit tab immediately. And tasks for printing. Okay, a shop sells a product whose regular price is A for, what do you mean A for B? Oh, okay. So A is regular price, B is discounted price. Oh. And what do we want to output? We want to print person that it is discounted. So I'm guessing A minus B over A. But then I want it to be floating numbers, so with high enough precision, I think something like this should work. If you slide one in between. Not exactly. I think you want to multiply by fractional 100. All right. Sounds reasonable. And another small test. I think the error is like 10 negative. Yeah, I think we are fine with that solution. Okay. Problem B, plays Snuke. I always fail to pronounce this name correctly. What do we want to do here? Takahashi wants to buy the popular video game console called PlayStation. Oh, okay, so PlayStation. Okay. There are N shops that sell PS. Shop 1 to N. Shop AI is Shop I is AI minutes walk from where Takahashi is now. Sells PS for PI yen and currently has XI PS. We'll go to one of the shops on foot and buy PS if it is in stock when he gets there. Okay, so PS gets and AI are integers, right? Okay. Okay. We're just going to make a for loop. I believe these things are, the shops are independent. For each shop, you can check if it's reachable in time, if it does not get out of stock. And if so, Think max price that he can pay. Okay, we are just going to go with this one. And then if best is equal, this means that we haven't found any shop. Otherwise, we just print best. This is not correct syntax. Okay. So basically, well, actually, we don't have to like do all the things. We can just have it here. So let me think. By the time we get to the shop at moment AI, exactly AI copies will be sold. So if xi is greater than AI strictly, then best gets minimum of best and pi, I believe. Here we have a bit longer input, so I will copy and paste it instead of input by hand. Yeah, okay. So answer here is indeed 8, answer here is -1, answer here looks reasonable. Like, so that in AI minutes that we spent working there, exactly AI consoles got sold. So that's why we have such condition, in case you were wondering. Problem C, unexpressed, given an integer n, how many integers between 1 and n inclusive are unrepresentable as some power, where both integers are not less than 1? Well, that's kind of classic. So the thing you want to do is like there are not all that many powers, right? Like the most ones that you have are squares. Another sets, I believe. No, that's actually, yes, that should be fine. So you see the thing, yeah, you definitely want it to be longer. And because of that, I believe, yeah, okay. Well, but yeah. No, plus b. Well, b is actually not important, if you think about it carefully. You have a loop like that. It loops over all powers. And inserts powers. Now, all you want to print is you want to print n minus size, I believe. Well, let's cast it to int just in case. And it's really not a good way to cast it to int, but where is mine? Yeah, okay, so we got, what is it? Is it 107? Yeah, okay. I mean, it's very reasonable. The reason why this works fast is because like this only goes up to square root of n, and then this loop only has log n operations in it. So we have square root of n log n solution, which should be fine. Yeah, 29 milliseconds. So, wasn't much problem. Problem D poker. We have 9k cards. For each I from 1 to 9, there are k cards with I written on it. We randomly shuffle the cards, and handed out 5 cards, 4 face up and 1 face down to each Takahashi and Aoki. You're given a string S representing the cards handed out to Takahashi, and a string T, okay. 5 characters each. Okay, yeah, I got it. The last character string is, okay. The score is I times into the CI. That's a complicated way to say. But what do we want? Like probability, right? We want the probability. The Takahashi wins. Okay. Okay, that sounds complicated. You really have to parse this formula. So it says like for each possible value, we count how many cards are with this value, and then we multiply it by value. With that, it gets to the power. Okay. Okay, so like basically the more cards of the same kind you have, the larger is the power of them. It's always beneficial. And then between these two, like whoever has a better card actually wins, right? That's a complicated statement, I must say. So it should be some DP, right? Like you can actually ignore this. But look, like there are 100 combinations of digits that hide behind the scenes, right? Behind the sharps. What if we just have a function named score? Make it strong reference. Well, that, okay. Oh, you know, I really don't like rice. What do I want? Some multiply action. So I times 10. I'm going to do it like this. So this is actually C, right? Okay. Because I have only 5 cards, it really does not make sense to have it anything but this. So now I have this, and what I'm gonna do next is like, well, from 9 to, yeah. Nope. So here we basically change in last character. So S4 gets I plus 0, I guess. P4 gets J plus 0. If score S is greater than score T, Then we have like p gets incremented by something, okay? As usual, let's actually make it 10, just in case. What is the probability? Probability actually depends on how many ways in which this could happen. Many ways to have I and J here and here. Given that we know like how many cards there are overall. For that, I actually need some paper, unfortunately. Unfortunately, because it really slows you down. I have K cards of each kind. Some of them already got used. That's the first thing I want to address. Now I know how many cards of each kind remains. Error 1, error 2, etc. error 9, let's say so. I want to figure out what is the probability that I get pair ij from such ri's and rj's. Probability that I get I in the first go is clearly ri over sum of r's. And the probability that I get j second is what? Is rj over remaining sum of r's, right? So it should not be complicated. Like here, remains of I gets decremented. Here it gets incremented back. Should be something like that. And like really sum only takes 10 operations to compute, so we are perfectly fine with that. Of course, you can make it in, no, okay. So R is the total number of cards that we have. Somewhere around here, I want to say something like line double P1 is actually remains I over R. And of course, I want to convert it to this. Somewhere here, I want to say like PJ, PI, and PJ. Let's make it. The name's reasonable. Calls this. Right? Well, here we actually don't have to change remains, right? Like this is completely useless. And I believe that this, no, okay, this is important because I might be equal to J. I'm a bit worried about floating point precision, but like we only need precision of 5. Why did I name it D4? It's actually D3. I would have a hard time figuring it out. Okay, let me see. This does not look like what we should have got. And it is kind of worrying. Okay, let's see how. Well, that's clearly not correct. For some reason, R, like probability gets higher than 1, which is clearly wrong. Because like even if he wins in every scenario, then here, sum of this over R is 1. Here, sum of this over R is 1. Like, how is it even possible? No, I don't understand. Well, actually, like one thing that you have to watch for is if remains at I. No. Like I wanted it here. I also wanted if remains in J. It should not change much just now. But it changes nothing. Yeah, okay, good. Well, not good, obviously. Let's just make it safe. So we have 2, 2, 2, 2, 2. Wait a sec. 1, 2, 3, 4, 5 2s, and then 8. Why do we have it again? R is initialized to 9Ks, and we decrement once per everything that we saw. Wait. 2, right? It means that we have 2 cards with each thing. We start with 18. Right? I don't understand. We start with 18. Right, because I decremented like necessary times. Remains also like, no, okay. If character is not a Yeah, now it makes more sense. So far, so good. I think this is actually 1932, 36, 71. It's actually correct as well. And I have 6296, 29, 74. Yeah, I think this is like pretty straightforward, although a bit long. So the idea is that we loop over all possible values that we can use. Wow, that's not great. Is it because, well, there's one thing that I can clearly fix here. Instead of doing all this, I can use this, this, this. And you see, I'm going to divide by r times r minus 1 only once. Should be careful though. This no longer matters. This no longer matters. This loop should work fine. I doubt that it makes any difference. Wait, am I the stupid one? Clearly I can't have that many digits, right? Yeah, I think I just messed it up with no good reason whatsoever. Yeah, it looks more or less like what we expected. Yeah, I think the problem was that we clearly can't have 5 of a kind, and I just did not include it for whatever reason I was thinking. I don't know what I was thinking about. Clearly, I was not thinking at all. Yeah, so sad. Well, never mind. Problem E oversleeping. Give me a sec. Yeah, I need to drink something regularly because otherwise my voice just gets like even messier than it is usual. Problem E oversleeping. The train goes back and forth between town A and town B, departs from town A at time 0, and then repeats the following. Goes to town B taking X seconds, to B taking, stops at B for Y. Okay, so it moves for X seconds, stops for Y seconds, moves back, etc. Half open intervals, okay. Takahashi is thinking of taking this train to depart town A at time 0 and getting off at town B. After his departure, he will repeat the following: be asleep for P seconds, be awake for Q seconds, okay. Half open, okay. Yeah, it's clearly an integer because it's beginning of one of the intervals. The constraints are very interesting. The train only stops for 500 seconds at most. And Takahashi is awake for at most 500 seconds, which is not much. Like 500 seconds is what? It's under 10 minutes, right? So we have several test cases, up to 10 test cases. So the first idea that comes to mind is, of course, some sort of simulation. I'm not sure how to do it efficiently. Not yet. I'm not really good at simulation, unfortunately. I have to check it carefully. So suppose we go to town B, X second passes. He's also asleep for B seconds. So in order for him to miss the first stop, Y should be, B should be, okay, it's not clear. Because P may be actually quite small. This entirely here and this here. Not exactly sure how we are supposed to use the constraints to our advantage. Because like my simulation that I have in mind suggests the following, like we just process events one by one. If whenever, for like whatever reason, we get back to the original state, then it's not possible for him to do anything about it because we are in a loop. And if we don't get in the same, like the question is how fast the simulation is going to work. It's not clear based on the constraints. Maybe I should read F because it's just not my kind of problem really. In which word you have to output infinity in words? Okay. Problem F, Zebraness. Given a grid of n horizontal rows and n vertical columns, so square grid actually. That's nice. Let ij denote 0, I, and j column. Character Cij describes the color. Okay. We have black and white. And some are not painted. Okay. Hash will complete the black and white grid by painting each unpainted square black or white. Let the Zebraness of the grid be the number of pairs of black square and white square sharing a side. Find the maximum possible Zebraness of the grid that Takahashi can achieve. And it's up to 100, so we have some room to spare. It's not like a huge grid. Want as many different pairs as possible. Like clearly we do not influence pairs that already exist, right? All we influence is we have like some region of question marks, entire region. And then we know like what are the boundary cells for this region. Like if these question marks do not share sides, then it's also trivial, right? But if they do, it becomes not very trivial. And the problem why they become non-trivial is because like you cannot do it with DP because once you process the square, when you select the square at IJ, it affects both next row and next column, and that's not great for DP. We don't have any constraints on number of question marks, so it should be still something. Like for each decision that we make, there's a part of Zebraness that comes from independent sources, like from the cells that are already painted. And there is a part that comes from adjacent question marks. And it's really not clear how to process any of this, to be honest with you. Let me just check standings to get a feeling like what, like 100 people almost certainly already solved everything. No, not really. Okay. No, I don't want to see this. I want to see all. Yeah, well, okay. Okay. Both of these appear to be not trivial, if I can say so. Really should not have made this wrong submission. Yeah, so a lot of people solved actually E, so I should think about it as well. Yeah, it looks harder than the previous one, I must say. Hopefully we can still pull it off. We have examples with 5, 2, we should leverage like somehow the fact that both P and Q are at most 500. Really should, and it's not trivial how we do it. Maybe we can just loop through all possibilities. Actually, what happens if like there are two possibilities really for Takahashi to get out of the train. The first one is when he is at position, like train arrives and he was awake for some Q prime, right? Q prime is from 0 to Q inclusive. Then Y prime is equal to 0. The second option is that a train has arrived for some time already. So Y prime is a times train has already waited at the stop. And then Q prime is 0. So either train was already at the station in Takahashi wakes, or train or Takahashi already was awake and train arrives at the station. Now for all these combinations, we want to find like what is the first time that we can encounter it. No. Yes. If so, then we want to output infinity. Oh wait, I can't do it like that. I think that the expression type has to be the same. So I actually have to do it not so good way. Best, I guess. We have like Q prime, which goes from 0 to Q not included because half intervals are open, all plus QQ, I believe. So that's what? That is train arrives. Arrives and wakes. What are the moments when train arrives? Actually, they are conveniently written here. This is the arrival time. So we know that 2x plus 2y times some n plus x is equal to what? Is equal to QQ is equal to P plus QQ modulo Q. I think so. Does it make sense? Like, no, modulo P plus Q is Takahashi's sleep schedule. And it should be like that. Yeah, I think so. I think so. It's not that we just have to solve this for n. Right? Like only unknown is n. How do we solve modular equations for unknown multipliers? Obviously, we have to divide. And then division is not always possible because you don't always have inverse. You have inverse precisely when you include them. Yeah, the modulo is not prime, so we have to use the different way to find inverse, which is of course extended to Euclidean algorithm. Let me just quickly find where it is. No, this is a different file. Okay. This is going to be our first sync. Then I think this is going to be our second sync. Yes, it's really just Euclidean, extended Euclidean algorithm. Some version of it, and it has an inverse. We'll just take Euclid GCD because we'll also need. Yeah, I think everything is long integers here. So that's what we have to do now. So we do have to check that 2 times x plus 2 times y d plus q is 1. Wait, what if it's not 1, but we still can't solve the modular equation? Like if this is also divisible, wow, that's hard. I don't know numbers here, I'm sorry. What is a legitimate way of finding the inverse? Well, of solving solution, we want to solve the equation. Why does he not have a code for this? This is really annoying. Should have thought it through. Okay. Not risky. So take G. Our A is this. Our B is this. Our N is P plus Q. And then we are solving the equation. No, that's the wrong N. Our modulo Solving the equation n times b equals a modulo m. Right? What do we do? We take GCD and we say like, okay, now we are going to solve this equation. Well, actually, like, so if a modulo g equal to 0, it has to be divisible, right? At this point, we again are solving this equation. And what we can say is like GCD now is clearly 1. And take your Euclidean inverse of b modulo m and multiply it with a, and we'll have again to take modulo m. Right? Okay, so we do have a solution n, right? Then the time, I think, is we just take best, we say best of best and n times 2. Well, actually, we were solving the equation n times b equals something, so this should be, yeah, we should be like this, I think. Now, what equation we are solving here? Train arrived some time ago, so we have 2 times x plus 2 times y times some m plus y. No, plus x plus y equals 0 modulo p plus q. The solving again for this guy over here. We have an equation like this. Let's actually copy this part over here. A is no longer this thing. A is p plus q minus x minus y. No, wait, we should really mod it out because this can be negative and our inverse does not work great with negatives, I believe. We should have thought through like why all these numbers here. It was very easy to prevent. We just messed it up. P plus q minus x minus y1. Still the same, still the same. Like this part is, I think, still the same. A has to be divisible by G. Yeah. Well, that's not really good test set, I must say. If you're given problems that involve all this little things, I would I would like to get a better test set. Yeah, of course it's M. Yeah. Well, that's incorrect. That's clearly incorrect. Let's figure out the infinity part, but then everything else is just a mess. For example, this is a modular equation, but this part stays completely legit, so we'll just have it like this, okay? And this part should stay like, no, I believe here it's plus x and here it's plus y. Why? Oh, never mind. It's just me being silly. Of course, this is not fun. Well, it's not exactly what I was hoping for. An explanation. So this is this case, right? This case is not handled correctly. And then just make it like this. Not sure if I can. That's much better. And I get the answer of 33, which corresponds, which falls in this case. Maybe this case is not exactly correct. Let's think it through again. So train arrived in there for some time. For y minutes to be precise. And I say, okay, y goes to that side. We're interested for this to be 0. No, we're interested for this to be p modulo, okay. I am not sure at all that this is correct. Like not at all. I kind of don't want to debug it with like no evidence that I should. So let's wait for one answer first. Oh no, okay, it gets accepted. So this was the correct idea. Cool. So we have like 500 times log for inverse and Euclidean algorithm or something like that. How is standing? So we should be a bit better, but not much, I think. Like this was not a trivial trick at all. Still a long time to go. Only 59 people solved this so far. Obviously, some of them are very smart. Some of them were not all that smart. Not of them, because they actually already solved it. Okay. Problem F. Now we really have to think about this kind of question marks painting scheme. Which I'm not the biggest fan of. Well, like, I'm glad that we solved it. It was a nice problem, actually. But we can solve this as well, let me think. We have some grid and we have question marks. And the problem is when several question marks are adjacent, like what do we actually do with them? It becomes unclear. Is there any form of greedy algorithm that may work, or do I have to use anything smart? Pretty sure I don't have to be particularly smart for that problem. The question is like, how do you actually proceed with implementing it accurately? By it, I mean some sort of maybe DFS to get the components of question marks, maybe BFS actually. Not 100% clear what I should do. How much time do we have? Also, I used entire hour for this. Now I have 14 minutes left for this problem. It's an interesting challenge. Let me pause the recording because I mostly won't be talking when I'm thinking. So I'll just pause the recording, and if I happen to solve it, I will be right back. So one very quick thing that I noticed is that if a cell, like if a question mark has two adjacent cells which are already colored in all the same color, then it has to go to the opposite color. Because our cost function is sort of local, sum of local functions. By that we mean that if you have already two white neighbors, and no matter what your other two neighbors are going to be, you want squeeze more than 2 if you go with white, and you can already squeeze 2 if you go with black. Right? Right? Does it make sense? Will this grid work actually? Not sure if we can make it actually now that I see. Because it influences what is about to go. Yeah, no. I'm not sure about 2 neighbors, but 3 neighbors is definitely the way to go. And then 3 neighbors don't occur all that often, right? That's unclear, but let's try. Yeah, the idea is like you want to get more out of this cell, but maybe you will get more out of the next one. That's really complicated for me. Let me think this through. No, that quick comment didn't work out, so I will take another. I'm not sure once again if this is going to work, Hear me out. Like, what if we compute for each cell, what is the max number of, it's not going to work. Like, I was trying to exploit the idea that for every like cell, there are only 16 states that its neighbors can be in. Like, there are at most 4 neighbors, and we have to leverage this somehow. Because on the arbitrary graph, the problem does not look solvable. So we have to somehow leverage this fact. The problem why we can't do it with DP is because it kind of goes row by row. But then it means that because each row can be like completely question marks, and we're going to have like 2 to the power of 100 states, which is completely unfeasible. So we have to do something smarter. We have to do something smarter. And I don't know what. That's kind of problematic here. Like for the beginning, I thought about some heuristics, how to cover up corners and maybe fill the interior of the shapes that we get. But I don't think that this is the way to go. I think that there must be some DP. Maybe something smart. Maybe you have to. Like obviously you want to know what is the state of the cell, but then the problem is that you want to know also the state of some surroundings of the cell, which is not great. Because they're kind of tied together. I don't know what to do about it. Non-obvious problems we have here today at ABC. That's kind of interesting. Let me think for a bit more.